So we're now going to look at the sum and difference rule, which basically just says if there's a sum or difference, so adding or subtracting, we take the derivative of each piece. Again, please remember to use the correct format for your derivative. That's really important that you're practicing that. So this would be dy dx. Bring down the exponent, subtract 1. Bring down the exponent, subtract 1. And remember, the derivative of any constant is 0. So my derivative here would be 6x squared plus 8x minus 3, because that would be x to the 0. And if you have a polynomial, when you take the derivative, you should decrease the degree by 1. So that should make sense. And if you couldn't add anything in the very beginning, you shouldn't be able to add it when you're finished. So that is my answer for number 13. Going to number 14, we first need to rewrite it. We will have some other choices later on, but if you can always rewrite a problem to use the power rule inside it, you want to. That's the easiest route to go. So notation here is f prime of x. Bring down my exponent, subtract 1, and I actually a lot of times just show that work whenever I'm dealing with a negative because it's super easy to do that part wrong. So I'm going to simplify now. Gives me a negative 6x to the negative third plus 2x to the negative 2. So you can write it that way or rewrite it with positive exponents. I've told you that my math lab will accept either one of the answers, but when you're just taking derivatives on the test, I actually will tell you on that page for almost all of them that I want positive exponents only. It just makes it easier to grade so that everybody's in the same boat. So my math lab's not going to mark you wrong, but I want you to kind of start practicing using positive exponents. So first thing I want to do on 15 is rewrite it. So that I can use the power rule. Don't let that square root of 7 throw you off. That is a constant. There is no variable, so the derivative of that is 0. So again, correct notation, dy over dx. I'm going to go ahead and do that first step here now. So 2 times negative 4 is negative 8. Subtract 1. Negative 4 times negative 3 gives me a positive 12x. Subtract 1. Gives me a negative 4. Bring down the exponent, subtract 1. The last piece is 0. I'm okay with you doing what I did there in purple, but on a test I can tell you right now you're more likely to make a mistake when you're trying to do it all in your head. So I'm going to take this problem and rewrite it with positive exponents only. Rewrite number 16, and at any time you need to pause this to work a problem first, it's actually a good idea. Make sure you have it down. So this would be x to the negative 1/2. I'm going to find my dy dx, multiply, and I'm going to show this so that you don't make a mistake. Remember, I can always put it over 1. Subtract 1 from that piece. This is going to give me a 5 over 1. So these cancel, remember, and the negatives cancel. So it's going to give me a positive 5. And when I subtract these, I get a common denominator. That's the same thing as 2 over 2. So that gives me a negative 3/2. So my positive exponents means move that 3/2 down. That's my answer. Going to number 17. This problem's a little different, but notice I'm dividing by a monomial, so we still want to rewrite it so I can use the power rule. We will learn that there's a quotient rule for this problem, but you don't want to use the quotient rule if you don't have to. It's actually a complicated format. So the better thing on this one is to remember if you're dividing by a monomial one term, you can break it into two different pieces. So that means y equals x squared plus 5 x to the negative 1 power. So I'm now going to take the derivative, dy dx, bring down the exponent, subtract 1, bring down the exponent, subtract 1. Rewrite the problem with positive exponents. dy over dx is equal to 2x minus 5 over x squared. Going to number 18. The key on this one is there is also going to be what's called a power rule, product rule. There's going to be a chain rule. We're not there yet. So in order to do this problem for this section, we actually have to multiply it completely out. So remember, this means x cubed minus 1, x cubed minus 1, x cubed minus 1. If you FOIL one of those pieces out, you're going to get x to the 9th, or sorry, x to the 6th, because we add our exponents, minus 2x cubed plus 1. Now you need to multiply that out again. I'm going to leave that for you to show yourself, but you would actually multiply x cubed times the whole second parentheses and a minus 1. So when I simplify and collect like terms, I should get x to the 9th minus 3x to the 6th plus 3x cubed minus 1. That is now my function. So I'm now going to take the derivative of that function, and it's actually a polynomial, so 9x to the 8th minus 18x to the 5th plus 9x squared, and remember the derivative of any constant is 0. Later we will learn how to do this problem using the chain rule, which actually will be easier to do for this problem. However, you can get the same answer this way by multiplying it out always. So I'm going to rewrite number 19, and you'll notice it just wants to also show you that there's another format you can use with that capital D on the outside. It's telling you to take the derivative with respect to x. So I'm going to first rewrite it. The first piece is good. The second piece I need to rewrite. So I'm now going to take the derivative of that piece, multiply by the exponent, subtract 1, multiply by the exponent, subtract 1. This gives me a negative 9/2, and I'm going to go ahead and put that exponent in the denominator. In this case, the 2's are going to cancel, so I'm left with a minus 3, and it's going to be a minus 3 over x to the 5/2 to bring that piece down. That is my answer for that problem. Reminder, what I did there, I had a negative 3/2 minus 1, and I can rewrite that as 2 over 2. That's how I got the negative 5/2 when I did that piece. These just take practice. The beginning ones are just going to ask you to do derivatives. The later problems are going to ask you to do exactly what you did back in chapter 3, where you had to find the derivative and evaluate it, and you had to find the slope in the equation. It's not a new concept. So here, first thing I got to do is find the derivative, which is 4x, because the plus 4 will be a constant. And now I plug in. Remember what that is. That is actually also my slope of my tangent at x equals 2, because that's what a derivative actually is. So that leads us to the next piece, where it says find the slope and equation of the tangent line to the graph. We did this test 2, hopefully. Slope just means find the derivative and evaluate it at that specific spot. So derivative, this is a polynomial, 4x cubed minus 15x squared. The constant goes away. So to find my slope, I'm going to evaluate that at x equals 2. So I end up with 32 minus 60, which is a negative 28. That is my slope. So I have a slope. I need a point. So remember, for your point, you use the original to get the y value. So f of 2, which is going back to the original problem, 2 to the 4th minus 5, 2 cubed, plus 2. That gives me 16. When I type that in my calculator, minus 40 plus 2, which gives me negative 22. So I have the point to negative 22. So here's my point. Here's my slope. Finish the problem. I again use point slope form. Distribute that slope to both pieces. Subtract the 22. That is my equation. So this question asked for the slope. My answer on my math will be negative 28. And the equation of the line, which is y equals negative 28x plus 34. Only difference to this section is now we can use the actual derivative rules and not use the difference quotient to find it. 22. Find the values of x where the tangent line is horizontal. Remember what the tangent line being horizontal, that means it looks like this, which means the slope is 0. So I have to find the slope of the tangent line and then set it equal to 0. That's what I'm doing. That means, back up, slope of tangent line means find the derivative. So go back to this problem. 6x squared plus 18x minus 60. That's my derivative. Now I'm going to plug in 0 for y, which is my slope. That's what I want the answer to be. This is a quadratic. We're going to pull out any like factor, GCF first, which I can pull out a 6. And then I can easily factor this to an x plus 5 and an x minus 2. This gives me x equals negative 5. This gives me x equals 2. What did it ask for? Did it ask for the points? Did it ask for the minimum? Did it ask for the maximum? This problem said find the x values. So I just did that. My answer would be x equals a negative 5 or x equals a positive 2.